Good afternoon, everyone. Wherever you are in the world, I hope you and your loved ones are healthy and safe. My name is Randy Bell, and I'm the director of the Global Energy Center at the Atlantic Council. Thank you all for joining us again for EnergySource Innovation Stream, where we aim to highlight new energy technologies with the potential to reshape the global energy system. Today, we'll be hearing from Jan-Justus Schmidt, co-founder and head of operations at Enapter, to discuss the latest advancements in the design, deployment, and scalability of hydrogen electrolyzers and Enapter's Anion exchange membrane technology. This is particularly relevant given the emphasis on advancing hydrogen technology in the EU's proposed green stimulus, which was just announced earlier today. Before we get started, two administrative details. First, you can follow us on Twitter at AC Global Energy and use the hashtag InnovationStream. Second, after Jan's presentation, you can submit questions through the Q&A function on Zoom, and I'll try to get to as many of these as I can. If you're watching on another platform like YouTube, unfortunately, we cannot take your questions. So please, let me welcome Jan to the Atlantic Council. Jan, thank you so much for joining us today.
Thank you very much for having me. It's a pleasure to be here and have a chance to present our company.
Oh, we're really looking forward to your presentation. How are you doing in these unprecedented times? I understand you're in Pisa, Italy, and are just being released from lockdown.
Yeah, well, it's special times indeed. So over the last few weeks, everything has been slowed down. While actually Enapter was able to stay open and mostly operational, of course, a lot of things around us were all shut down. Now it's really opening up again in Italy. Things are starting to get back to normal. And in June, actually travel between regions and internationally will be allowed again. So it's looking like, in Italy at least, it's looking good.
Yeah, that's great, and glad that you were able to stay healthy in what was very challenging for Italy. It's also great news that hydrogen is being emphasized as part of the green stimulus, and so good that your technology is getting ready to go and is already out there in the world. Really looking forward to your presentation. So if you can share your screen and get started, we'll have about 10-15 minutes of presentation, and then we'll have a Q&A with the audience. And I see we already have a really great crowd who's joined us. It's a fantastic turnout. So remember, you can start putting your questions in the Q&A. So Jan, why don't you share your screen and get started?
Very good. Okay. I think now you should be able to see my screen. So yes, Enapter is a fast-growing company founded about 3 years ago, and we make AEM electrolyzers for hydrogen generation from electricity and water. So this is particularly relevant, and as Randy just mentioned, the stimulus bill focusing on hydrogen. There's a good reason of this happening, and this really big interest in hydrogen at the moment is because green hydrogen specifically is essentially the only way that we can decarbonize all of the energies vectors that we have using renewable electricity. This particularly in transportation, in industrial use of energy, and in mobility. We are fully dependent still on on fuels, fossil fuels, and the only way to decarbonize all of these energy sectors is by taking renewable electricity and using it to produce hydrogen. And this is what Enapter is doing. So with our AEM electrolyzer, we have a particularly good way of turning renewable electricity and water and producing hydrogen gas cost effectively. So in essence, we produce this machine, we take in electricity and water, and we produce hydrogen gas. We're really focused on this aspect of it. And the product from our machines is then used in all kinds of different industries to produce in energy storage applications, and to produce synthetic fuels, and also in direct use in industry and for refueling of hydrogen vehicles. Within this industry, Enapter has a very different approach than anyone else working on hydrogen generation. Our focus really is to go towards to develop a product, a scalable and modular product that can be easily deployed very quickly and that can be mass produced. So the analogy is similar to the PC industry, where in the modular personal computers have replaced, very large mainframe computings. By going for small, modular, mass-producible components, the costs can be reduced much more effectively than if we see each hydrogen generation plant as a singular large project. This is our product, the EL 2.1. So with each of these modules, we produce 0.5 cubic meters of hydrogen gas per hour. And one of the great things about this module is that in the last 2 years, we've released several versions of this product, and every time we've been able to significantly improve the efficiency and reduce the cost of this technology. So with the current system, we actually only consume 4.4 kilowatt hours to produce 1 cubic meter of hydrogen, which is a phenomenal value for electrolyzers nowadays. So, for example, the METI goals, or the Japanese government, which is also really pushing on hydrogen very strongly, they have a goal for 2030 to achieve an efficiency of 4.3 kilowatt hours to produce a cubic meter. So 10 years ahead of that schedule, we're already very close to achieving these efficiency goals. The reason one of our machines are extremely easy to use. So we have these modular stackable devices. Each one only needs a power supply, a water supply, and then you will get directly compressed high purity hydrogen from the machine. And the reason why we are able to build such a small and compact building block cost effectively is due to the unique anion exchange membrane technology that sits in the heart of this machine. So essentially, there's 2 types of electrolyzers established in the market: traditional alkaline and PEM electrolyzers. And with AEM, we combine the benefits of both. We do not need to rely on expensive noble metals for our catalysts. By working in a slightly alkaline environment, we don't rely on titanium, for example, for our current collectors, bipolar plates, and so on. And so this allows us to build a really low-cost stack, which is the core of the electrolyzer machine. The other benefit is that by using this solid polymeric membrane in the middle, this is the anion exchange membrane, it actually separates the oxygen gas and the hydrogen gas, and it creates a very safe working environment where we can quickly ramp up and down, and we can produce hydrogen directly under pressure and with a very high purity. So that means that after the stack, we don't need to do a lot of purification or any other steps. The hydrogen can be directly used in most applications that our customer have for the hydrogen. This technology is relatively new. It was discovered about 10 years ago by an Italian team of chemists. And this is also why I'm sitting here in Pisa, where we still have our R&D and also our first serial production of these machines. The other focus that Enapter has since the beginning is on software. So we see that by building these modular building blocks, it's very important that we give our customers the tools to be able to easily deploy these into all the various different projects that they're doing around the world. So we have a very strong software suite that consists of mobile apps, web dashboards for monitoring the devices, and gateways that allow you to combine many devices together into one large system. So it's actually a matter of installing the piping on all your electrolyzer systems, no matter how many of them you connect together. Then taking out the mobile app to start up the system setup, scan the QR code on each module, and then they will all work together as one large electrolyzer system. We also make it easy to integrate other types of third-party devices and other types of technologies by supporting a wide variety of different industry-grade industrial communication protocols, such as Modbus, CAN bus, and so on. So our devices and our energy management system can talk not only to Enapter electrolyzers, but also to different kinds of sensors, other fuel cells, and whatever else might be included in the energy system that our partners are building around the world. And this slide shows the general architecture of our energy management system. That makes it very easy to build these electrolyzer systems, hydrogen energy systems, using our EMS. These slides will also be available also, so anyone can look at these later on in more detail. So we have already set up our serial production here in Italy, and currently we are planning for the automated mass manufacturing of our electrolyzers, which we hope to have up and running within the next 2 years. But already now our product is being produced, it's sold in the market, and we have various use cases all around the world for all kinds of different applications. So here on this picture, for example, we see a great example of long-term seasonal storage where batteries are really not suitable for. Here in this refuge in the French Alps, our electrolyzers producing hydrogen over the summer months, and then in the winter when everything is covered by snow, the fuel cell can be used to produce electricity and heat for the skiers that take a rest at this refuge. The other use cases that we have really span all the different applications of hydrogen. Our electrolyzers are used for on-site production of hydrogen for refueling cases, such as hydrogen drones. But we also have cases for refueling stations of forklifts and of passenger cars and even snowmobiles. One really interesting application of hydrogen is heating. So many European countries, especially in the Netherlands, this is a really growing interest in this field to decarbonize also the heating sector. So there's a very nice use case showing also the modularity of our system with many electrolyzers, 8 electrolyzers combined into a larger system. In Rosenburg, which is actually a test bed for testing the hydrogen boilers to heat up an apartment building with hydrogen. We have industrial use cases where hydrogen is used, for example, for nitrogen purification, but also for ammonia production in the glass industry to make gemstone processing and all kinds of other applications. This particular case in Australia is also really interesting because green hydrogen here is actually not the end product, but it is combined with CO2 from the air. And the idea is to build this modular system that is realized here and to produce synthetic methane gas that can be used for domestic use, but also specifically for exporting Australia's sunshine. And so by using small mass-produced components and putting them together into very large and multiplying them very often, these economies of scale actually allow you to build a lower cost synthetic gas production than with a centralized plant. And then, of course, there's a residential storage application. So this is a system in Germany where the homeowner is off-grid with solar and battery and using hydrogen for the daily cycling and using hydrogen for the longer-term storage in addition to become completely independent from the grid. This is an island system, so another long-term energy storage application, which is one of the most interesting cases for small decentralized electrolyzers. So we can actually replace the fuel deliveries to all of the hundreds of thousands of diesel generators that are sitting all around the world, powering remote telecommunication masts and remote villages and so on. Our target is to continuously reduce the cost of hydrogen generation using our electrolyzers. And so as soon as we have our mass manufacturing site up and running, and before the year 2024, we want to be producing hydrogen at a capex cost of below €1.50 per kilogram, at which point it becomes cost effective with fossil fuels in many applications. This is really, and there's really no limit to what can be achieved with hydrogen. So this is our big focus for the next years is to achieve this mass manufacturing and to continue to bring down the cost. I hope that this gives you a good overview about where our company is at, what our technology is about, and I look forward to answering all your questions.
Jan, that's really fantastic. Thank you. If you could stop sharing your screen. Oh, perfect. We are starting to get a lot of great questions from the audience. We have a really good turnout today. I have 7 questions in my queue. This was a really fantastic actual follow-on to a conversation we had here on Innovation Stream 2 weeks ago with Michael Weber from Angers and the University of Texas. And I believe Michael is on the line today. So that's fantastic. Michael, if you have any questions, feel free to ask them. And if you really want to be on camera, we can actually cut to you. So just let us know so we could ask that question live. You can message me through the Q&A if you'd like. I want to ask a couple of my own questions first before we go to the audience. So just number one, where are you seeing the most immediate first opportunities for commercial deployment? What's happening right now? What is already out there deployed?
Yeah, it's a very good question. So of course, like I showed, that there's really a lot of different applications for hydrogen, and so roughly they can be grouped in 2 situations and 2 kind of applications. There's one that is the future energy market, where we are looking at long-term energy storage. We're looking at hydrogen storage for neighborhoods and so on. We're looking at vehicle refueling and all these applications where green hydrogen can really help to decarbonize new renewable energy applications. However, there's also another part, which is the existing hydrogen market, which is absolutely huge. So there's already hundreds of tons of hydrogen used every year for ammonia production, so most of the world's fertilizer production, in steel making, and lots of different kinds of other industrial applications. And these are also really, really interesting, and probably more interesting than we initially expected. We have more interested than we initially expected at Enapter also in these applications to start to decarbonize these existing industries. So it's really hard to say. We see actually everyone moving towards hydrogen because there really isn't another good way to decarbonize many of these industries.
Fantastic. Thank you. So since I called out Michael Weber, I'm going to go to his question first. Michael, thank you. He asks if you can describe the water quality requirements in more detail. Water purification can be energy intensive, he notes.
Yeah, that's right. So this is one of the nice things about our technology, because we are working with a very diluted alkaline solution that is circulating within the system only on the anode side, on the oxygen side of the electrolyzer. So this solution actually acts like a buffer towards impurities in the input water quality. So the cleaner the input water, the less conductivity, the less dissolved solids there are in the input water, of course, the better and the longer the maintenance intervals can be. But we do have, with our technology, we do have a very good resilience towards impurities in the input water. We can work with input water up to a conductivity of 20 microsiemens per centimeter, which can be achieved with most simple reverse osmosis and resin filters around the world. So it's much less intensive and maintenance intensive than if you have to guarantee a conductivity below 1 or even below 0.1 microsiemens per centimeter, as you have to do with other electrolyzers.
Fascinating. Michael, thank you for that question. Really, really interesting question from Vinay. I'm going to massacre your name, unfortunately. Vinay Mogandath. Can your system support rapid ramping up of hydrogen production to support demand-side management services? So along the lines of something we were talking about beforehand. Instead of curtailing excess power, can you support the rapid ramping of the production?
Yeah. So essentially, it's the cell setup is very, very similar to a PEM electrolyzer. So there's no limitation there. As long as the system is at an operating temperature and is ready to go, then you can ramp up and down in fractions of a second. So there's really, in theory, yes, absolutely, you can do this. So we don't have any applications in those kind of services yet. which is probably due to the size of our standardized of our module. Each electrolyzer is just 2.2 kilowatts, but definitely you can stack them together to form large systems, and then you have two ways to control them. Actually, you can shut just a certain number of electrolyzers on and off as you like, or you can ramp the production rate of each one individually. So there's a lot of flexibility there, and the response is extremely fast.
Yeah, that's fascinating. We have a really good follow-on question to that from Guido Bortoni, who is asking about scale. Since you talked about combining, putting multiple electrolyzers together, is there an upper constraint to scale your technology? Can you think in megawatts, for instance?
Yeah, absolutely. So today we don't have any systems of that scale yet, but we are definitely, we think that our technology absolutely can do this. So there is, with each cost reduction that we are able to implement and bring to market, the upper limit of where it makes sense to combine our systems together grows up. So we think that currently it makes sense to put our electrolyzers together with the current system to make systems up to 100, 200 kilowatt range. And we also see a very clear path to build megawatt electrolyzers, still following the modular concept that we have now within the next few years.
Fascinating. Okay, a really interesting question from Vincent Oldenbrook from the African Hydrogen Partnership, who asks, do you already have partners with a complete solution of solar, battery, electrolyzer, hydrogen storage, and fuel cell independent power supply? So essentially a all-in-one package where you can have that ski chalet generating hydrogen, but just buy it as a one-off off the shelf or order it from Amazon.
Yeah. Absolutely. So we Enapter, we are a technology provider. So we sell these easy to use modular, building blocks that can be used to build such systems in as easily as possible. So we also we've built a few of these all-in-one complete setups ourselves. And we are very happy to share all of our experiences that we have with those kind of things to help to grow this network of partners all around the world that is able to build these solutions. And so, yes, absolutely, we have a partner network that we are actively growing around the world, where they will combine our electrolyzer with third-party devices such as storage tanks, fuel cells, and so on, to build the customized solutions for the final users. So if we will have more information on our website also coming up soon.
Fantastic. Well, I look forward to seeing that, and I look forward to being able to buy my complete system right off the shelf when it's ready. We have a couple of questions relating to how you think about getting the price down, both from Cameron Terry and Vinette Sharma. So how do you anticipate reducing it to 1.5 euros per kilogram? What is the plans to bring the cost of production of the electrolyzers down?
Yeah. There's two big levers. So one is that while we are very happy with our technology, there's still a lot of stuff that we can do. So we've increased in the last 2 years, we've managed to already increase the current density. So by more than 40%, which means that we now need 40% less material to produce the same amount of hydrogen as we did 2 years ago. And so R&D is one big factor. We continue to invest into our R&D and grow our team to bring improvements into the product. And the other really, really huge lever is manufacturing scale. So having a standardized product is incredibly important, because we can then, rather than tailoring it for each individual project, we can take advantage of automated manufacturing. We can take advantage of economies of scale in the manufacturing line, and this will bring about the massive cost reductions.
And a question from Everett Anderson that goes right to that is, what's the time frame for this mass production facility, and what would the capacity be, at least initially?
Very good question. So yeah, the time frame is 2 years. So we want to build our largely automated mass production facility within the next 2 years, and then the capacity will be initially we're looking at around 250 megawatts per year capacity.
Got it. Got it. Okay. An interesting question, again from Vinay, whose name I cannot get right. Mulgan Math. When do you think there'll be price parity between blue and green hydrogen? So how are you thinking in terms of blue and green hydrogen? You mentioned at the beginning of your presentation that you see, green hydrogen or hydrogen from renewable energy sources is really the path forward. I know there's a lot of talk also about blue hydrogen from using carbon capture. How do you see price parity there?
Yeah, I got to be honest. We're completely focused on reducing the cost of green hydrogen. So there's a lot of topics on blue, gray hydrogen and how to make that climate neutral and so on. Actually, I can't really comment too much on that. I know that there's significant issues with permanent storage and so on of CO2 and what to do with it. So I'm not saying that there won't be any blue hydrogen generation. I'm sure there will be in some applications, but I think that on a widespread scale, green hydrogen will become most cost-effective solution simply because of the vast amount of renewable electricity that will be available in a few years.
Got it. I'm going to ask a question of my colleague Olga's, which you noted that your technology requires no noble metals. Does this at all alleviate any supply chain risk by essentially using more common materials? Do you have any? You hear about worries, particularly on rare earth metals, a different thing. But do you worry about? Does this solve any supply chain problems for you?
I mean, it's an advantage. I think I don't know how much real supply chain issues there are with sourcing platinum, for example, which is already used heavily in the automobile industry. So I don't know if it's really so much of a supply chain issue, but it's definitely a cost issue. And especially by working in this low alkaline environment, not relying on platinum, iridium, and actually the biggest factor is titanium, is the reason why we're able to produce very low cost technology.
Great.
But yeah, just to get back to the point, yes, it is a really big advantage that we do not have to rely on any difficult to source raw materials, and actually electrolyzer production can be done anywhere in the world. You're not reliant on a particular single source of any kind of raw material.
Yeah, so there are real energy security benefits from this type of technology.
Absolutely.
That's fascinating. Okay, one final question before we have to wrap up, coming from Dmitry Besarabov, which is, what is the typical current density of operations for your products?
All right. Currently, we operate at 0.8 amps per square centimeters, and of course, we are looking to push this more and more to reduce the cost of our technology. Yeah, that's the answer.
Okay, and well, since it was quick, I want to take this last question that just came in from David Miles, who is a microgrid developer across the Caribbean, and was wondering if you could translate it into cost per kilowatt hour.
It's a very good question. That the answer here is I cannot really, because it very much depends on the complete system. Actually, our team published recently an article about how we think is the best way to compare the cost of electrolyzers, and express it in terms of euros per kilogram of hydrogen generated. That is part of the capex of the electrolyzer and part of the opex of the electrolyzer, and to look at those all separately. So that's a really interesting piece to understand the economics of green hydrogen production from electrolyzers. But if you're looking at understanding the cost of the final electricity of your island microgrid, you have to look at, what does it cost to make the solar panels? Then what is the configuration of your battery and hydrogen storage? All the different components that are put together. So this will very much depend on your load profile and on the different components that you've chosen there. And this is, and it will depend very much on each project. It will be different, very different on each project. So this is actually not something that Enapter can do, but this is where our partners will come in and be able to configure the kind of setup and then calculate exactly the cost of kilowatt hours of energy from a specific setup.
Jan, thank you so much. This was really fascinating. I know I learned a ton, and I look forward to following Enapter as it scales its production. Thank you, everyone in the audience, for tuning in, especially for those repeat people who keep joining us every week. And you can really, Jan, thank you again for your presentation. You can follow Enapter on Twitter at Enapter_. This presentation will be available on the Atlantic Council website, YouTube channel, Facebook, and Twitter. So please do share it with your colleagues who you think will find it interesting. Please stay tuned for the next edition of EnergySource Innovation Stream. We're finalizing the timing. It looks like it's going to be next Friday, June 5th. But our next edition will feature the company SICPA, who's going to discuss innovation in fuel integrity. So more info on that soon. So please check out the Atlantic Council website and Twitter to find out more on that. I hope you will join us tomorrow at 8 a.m. Eastern Time for the virtual launch of the Atlantic Council's latest report, European Energy Security and the Critical Role of Transatlantic Energy Cooperation. Ditte Juul Jorgensen, the Director General for Energy at the European Commission, among many others, will join us for what promises to be a highly relevant conversation about the future of energy in the EU, particularly with the green stimulus and the European Green Deal taking center stage, and with the emphasis on hydrogen. I think you're all going to be interested in that conversation. Finally, let me thank everyone who made this program possible. Olga Kakova, Matali Merla, Zeynep Wirinen, and Roger Morales. Until next time, everyone, hope to see you again, and please wear a mask. Have a good afternoon.